All right, ladies and gentlemen, our topic today is dilations. You'll have to pardon my handwriting. I'm writing with a computer mouse instead of my pen because my pen broke. So our objective today is I understand how a dilation changes an object and how to complete a dilation. It's a pretty simple video. It's nice and short. It shouldn't take too long. Okay, so a dilation is just another kind of change you can make to a geometric object. And dilations are done just like transformations on an XY axis. It's not too difficult. So an important difference between a dilation and the transformations we have done is that a dilation changes the size of an object and it doesn't change the relationship of its side. So while the sides will be different lengths than they originally will, because it will be bigger, the angles between the sides will be the same. So it's going to create a new object, the image. And I paused my video and I have no idea what I just said, so I'll start at a logical place. So when you do a dilation, it creates a new object that is similar to the first object. And in translations, reflections, and rotations, the two objects that you have, the original and the image, are congruent, which means they are the exact same shape and size. And here's where my handwriting is going to be awful. Bear with me. Same. Oh God, this is terrible. Shape. And size. And this is why I bought a pen in the first place. I promise I will get it working by the next time I make a video. Okay, so in a similar figure, they're the same shape but different sizes, and that's what's created when you do a dilation. So when you have a dilation that you need to do, you're going to be told the scale factor. It might say dilate the object by a factor of 3 or 2 or 1/2. And it's going to tell you how much to change the size of the. So the scale factor can be any number greater than 1. It could be 1/2, it could be 0.8, it could be 3, 10, 1,000. As long as it is not a negative number, we're good to go for the scale factor. So let's look at an example. I've got a little triangle down here, and we are going to dilate this figure by a factor of 3. And the way we're going to do that is by taking the x and y coordinates of every point in our original shape and multiplying them by the scale factor. So first we have to find our points. This is point A, B, and C. So point A is at -2, 1. Point B is at 2, -1. And point C is at -1, -1. And what we're going to do is we're going to multiply all of these numbers by our scale factor. Our scale factor in this case is 3. So A becomes A prime, which is now at the point -6, because -2 times 3 is -6, and 3, because 1 times 3 is 3. B prime, we multiply the x and the y by 3 again, and we get 6, -3. And C prime is going to be -3, -3. That's an awful C. Okay, so now we have the points of our image, the points of our dilated object, and now we simply have to plot them. I made an error. Point A is not at -2, 1. I am terribly sorry. It is at -1, 2. If I had a rewind button, I would use it. Apologies. So the new point is going to be at -3, 6. Sorry to confuse you guys. Okay, so now I plot the new points. So A prime is going to be 1, 2, 3 to the left and 6 up. 1, 2, 3, 4, 5, 6. There it is right there. That's A prime. B prime is going to be at 6, -3. 2, 4, 6, 1, 2, 3, right there. And C prime is going to be at -3, -3, right there. Now I just connect those dots with straight lines, and you can see your dilated object take form. As you can see, it is the same shape, just a different size as the original object. Okay, this next one I want you to try and figure out on your own. I'm going to pause the video. You should pause the video while you figure it out. Actually do this. Do not just skip ahead and take the shortcut. And we're going to dilate the following object by a scale factor of 1/2. Okay, I'm pausing the video in 6, 5, 4, 3, 2. Okay, so as you can see, I have plotted the coordinate points of my image, my dilated object. The first thing I did was write my original points of the original shape. I've got -2, 4, 6, 4, 6, -8, and -2, -8. Then to take a scale factor of 1/2, I have to take half of each number in my ordered pair. So half of -2 is -1, half of 4 is 2, and on to get all the coordinate points of my image. And when I'm all done, I plotted those, connected them with straight lines, and I have rectangle A prime, B prime, C prime, D prime. If you plot the points for what you think they should be in the image, and it doesn't look like the same kind of shape as you started out with, that's a big clue that you did something wrong. If it looks like it's like the sides are different relationship to each other. Remember, the original A, B, C, D is going to be similar. Anytime you do a dilation, the shapes are similar. So it's going to be similar to A prime, B prime, C prime, and D prime. Okay, for your reflection to type into Edmodo, you need to dilate this object by a scale factor of 2. And you're going to have to list the ordered pairs of all the new vertices of this pentagon in Edmodo. So there are 5 vertices. You need to tell me the ordered pair of each one on your new image. Okay? Look forward to seeing your responses. Have a great night. I'll see you tomorrow.